course, made of the kidney. So first we will focus on the nephron. First one is the renal corpuscle. The renal corpuscle is enclosing a tuft of capillary loops and is a site of blood filtration. So everything that passes through the kidneys are filtered, including the blood. So those patients who are undergoing dialysis, the ones that are having chronic kidney disease or kidney failure, they are usually not capable of filtering the blood anymore. So the dialysis machine is the one doing it for them, because if you don't dialysis a patient and then their kidneys are already failing, so whatever bacteria, circulating bacteria or pathogens that will enter into your bloodstream, if the kidney cannot filter it, so the patient will, of course, have an infection, and then worst case scenario, they will have sepsis, septic shock, because there will be multiple organ damage. So renal corpuscle is very important as part of the filtration system of your kidneys. So the location is in the cortex. It also contains the glomerulus or the Bowman's capsule. Okay, the glomerulus contains the afferent and efferent arteriole, and then it is lined with a simple squamous epithelium and has the fenestrated capillaries. And then the Bowman's capsule has the parietal and visceral layer, which contains the simple squamous epithelium, also with fenestrated capillaries and the podocytes. Okay. So podocytes is food processes in the kidneys, in the Bowman's capsule. Okay, so this one. So we already flashed this picture a couple of times. So again, this is the glomerulus, the Bowman's space, and then the whole thing is a Bowman's capsule. The capsule surrounding the whole glomerulus. So the lining of this is the simple squamous. And then these are the capillaries, and then the food processes or the podocytes. And then this white space here, it's the urinary space. So that contains your urine. Okay, so this is the distal convoluted tubules here on the right. And then this one, the darker ones, is the proximal convoluted tubules. Okay, so there are three main functions of the kidneys. So filtration, tubular reabsorption, and tubular secretion. So filtration, of course, the water and the solutes that pass through, and then it travels from the blood vessels to the tubular lumen. For tubular reabsorption, it's from the tubules to the blood vessels. And then when they secrete, tubular secretion is the other way around. It's from the blood vessels to the tubular lumen. Proximal convoluted tubule, so it is lined with simple cuboidal epithelium located in the cortex. So this one, so it's simple cuboidal. So the Bowman's capsule is simple squamous. The proximal convoluted tubule is simple cuboidal. And then its function is to reabsorb all inorganic nutrients, proteins, and mostly water and electrolytes, and it is responsible for secretion of organic anions and cations like hydrogen and the ammonium. So, ang PCT. Loops of Henle, two parts, the thin and descending, which is lined with simple squamous epithelium located in the medulla, is served to passively reabsorb sodium and chloride. And then thick ascending loop is lined with simple cuboidal, is located as well in the medulla. They are the ones that are actively reabsorbing the electrolytes. So the thin lips are only passive reabsorption. The ones that are active reabsorption is in thick ascending loop. For distal convoluted tubule, it is lined with simple cuboidal as well, like the PCT, the proximal. It is located in the cortex, and it is also responsible for reabsorption of electrolytes. Okay, ureter. The ureter has the walls and then the mucosa. So the walls contains 3 layers: the mucosal, the muscular, and the adventitial layers. And then they become thicker as they go closer to the bladder. And then the mucosa, it is where you find the transitional epithelium or the stratified urothelium. And then there are 3 layers: a single layer of small basal cells, and then the intermediate region where 1 to several layers of cuboidal or low columnar cells are found, and then the superficial layer, which contains the elliptical umbrella cells. They are sometimes binucleated to protect the underlying cells. So that one. It was already used in the first chapter as an example of transitional epithelium. So the ones on the surface is the umbrella-shaped or the dome-shaped cells. And then the one below is the transitional epithelium, the mucosal area. So as illustrated here, when the bladder is stretched, so the cells become flattened to accommodate urine. So that's why it's transitional, because it will transition from one shape to another to accommodate something. So like this, transitional epithelium, they will accommodate the urine, so they will stretch so that they can contain the urine. Okay, so this one is also an illustration up here. So this is the umbrella cells on top. The intermediate cells, the intermediate region, where you can see the cuboidal cells, the basal layer, and the stroma. So that is the transitional epithelium. Okay, next. Bladder contains the submucosa and the muscularis. The submucosa has the lamina propria and dense irregular connective tissue, which are highly vascularized in the submucosal layer. And then for the muscularis layer, there are 3 layers. It contains a detrusor muscle. So the detrusor muscle is the one that will contract to empty your bladder, and then it has valves to prevent the backflow of urine to the ureter. So that is the function of the detrusor muscle found in the muscularis of the bladder. For urethra, it carries urine from the bladder to the exterior. So urethral mucosa has prominent longitudinal folds, and in men, the 2 ducts for sperm transport during ejaculation joins the urethra at the prostate gland. So unlike in females, the urethra is separate, but sa male, they join the ducts, the sperm ducts, join the urethra at the prostate gland. So isa lang ang exit. So urethra in male, so it is longer than female. There are three types: the prostatic urethra, the membranous urethra, and the spongy urethra. So they have different epithelium in each part. So the prostatic urethra has the transitional, membranous urethra has a stratified columnar and pseudostratified columnar, as well as a spongy urethra, but they will change into non-keratinized stratified squamous distally. So wala na yung difference sa membranous and sa spongy. They are the same epithelium, but distally it will change into non-keratinized stratified squamous. So for female, it's only transitional to non-keratinized stratified squamous. Okay, that's all. Alright. Do you have any questions? Very short lang din ang topic sa urinary system. For your laboratory part on this, since it's only once we already covered the glomerulus and the urethra with the transitional epithelium, so what you will demonstrate is the same, no? Or I don't know, do you I haven't checked your lab manual. I think there's no activity for the urinary. But if there is one, you can reuse the pictures, no? Because it's still the same. Excuse me.
Ada may quiz.
Naman may quiz gay ka man mo ko discuss.
Okay, sorry. Let me check first if you have the. I think the last exercise in your laboratory is the 13B.
Yes, doc.
Yeah. So there is no more urinary system for your laboratory. And then for the embryology, of course, there's no laboratory in that. There is a supplementary lecture. So I will just get a few questions from your exam. But the main questions, I will get it from those that we have a lecture module and we have a laboratory, because embryology is only supplementary for your course. It's not the main thing. The main thing is the histology for your before your general pathology next school year. So I will just, what do you want? Do you want to take the quiz now, or do you want to take it later at 4 o'clock? It's only 10 points.
Pwede mo mo yun?
Pero mo niya, mababasa ba kayo ng mga?
Hindi na.
Okay, I will just I will post the quiz at 3 o'clock, and then just wait for it to open. I will open it for 30 minutes, and then after that, our next lecture is tomorrow afternoon for the embryology, very short as well. Okay, so that's all for this afternoon. Thank you everyone for listening.